Hi, my name is Rob. I'm from Mager Scientific, the digital imaging sales specialist here. I wanted to show you today the integration of our digital microscope system into Nikon Elements software and show you some of the highlights and features of the software. So there are two major functions I'm going to show you today on how we integrate the digital microscope with the software. The first major component is this motorized Z drive. This allows us to go in and automatically create all-in-focus images when we're looking at samples where we can't get everything in focus in one plane. So first I'm going to show you a very simple technique. Here we see we have an image where as I focus up and down, different parts of the image are in focus and I can't get them all in focus at once. So we have the ability to come in and go to the real-time EDF manually choice in our menu, and I'm going to choose Create Z-Map and I'm going to hit Start. As soon as I hit Start, we'll see two images. The image on the right is the live image, and the image on the left is going to be the image that is going to be created. And I'm simply going to take my motorized Z drive and slowly move down through the Z planes. So you can see the image on the right changing focus. And as I go through the different focal planes, the image on the left is being built into our all-in-focus image. Once I've gone all the way through the sample, I can hit Finish. And I'm done. I've got now one image where everything's in focus. And there's one more thing I can do based on the fact that we've got a motorized Z drive here. I can create a quick 3D topographical map, which is what a lot of people like to see. So I hit this icon at the top. And this just gives us this view of the image with some depth profile. You can see the depth of 0 to 1.4 millimeters on the right-hand side. And this gives me a view that I can create a single image of. I could make a rotational movie of this to put in a PowerPoint presentation. And I can even go in and do some real simple measurements with my measurement tool here. I can click on this surface and this inner surface and see that I get a height measurement of 1205. So the next technique I'm going to show you is EDF with HDR. So HDR is high dynamic range. The software has the ability to capture images and get rid of the glare that quite often happens when you have shiny parts such as these solder joints in this circuitry of this hard drive I'm looking at. So to do this, I'm going to go into a menu called Real-Time EDF. And in my EDF menu, I'm going to reset what I had been working on before, and I'm going to focus to the top of the image, and I'm going to hit Top. Then I'm going to use my motorized Z to focus to the bottom focal plane and hit Bottom. And then I can click this button for the software to determine the optimum number of steps. It says 28 for demonstration purposes. I'm just going to do 10 for today. And I'm also going to check Use HDR. So I'm going to do an EDF with HDR, and let's see what the results are. I'm just going to hit Run. So after this is through, we end up with our all-in-focus image with a lot of the glint and glare taken out of the image. And we still have the ability to go into our 3D topographical map and see that view of the image as we saw earlier. And we could also come in and still do our height measurements by using our measurement tool over here. And again, create 3D rotational movies or just pictures of this view here. So now let's talk about the XY motorized stage. Here we have a situation where I have my sample. I'm at the lowest magnification of my microscope, but I want to see a little bit more than what I can fit into one field of view. There comes the XY motorized stage benefits. I go into my Scan Large Image dialog box, and there's several different ways to do this. I'm going to do a simple set up my scan by defining my top, bottom, left, and right. So you can see in this area of the software here, I've chosen that. So I'm going to navigate with my joystick to the top of the area I want to image, and then navigate to the left-hand side, let's say right there. And then I'm going to scoot down a little ways and call that my bottom, and then over to the right and call that my right side. Right now that's all I'm going to do. I'm just going to hit Scan, and we're going to let the software do the rest. And as you can see, it's going to create, in this situation, for that area I wanted to capture, about a 2x2 image. It creates the thumbnails in the top right, captures these 4 images, and then at the end goes ahead and stitches those images into one large image, which can be saved just as a simple image. I can do measurements, put scale bars on, and that is the benefit of the XY motorized stage. So now we're going to put together the capabilities of the XY stage and the Z drive by doing image stitching and EDF together. So here we're into my Scan Large Image dialog box. Over on the right top side, I'm choosing to do an EDF as I do my image stitching, and I'm going to do 7 planes. Over here in the area, I'm going to do it a little bit differently. This time, instead of defining my top, bottom, left, and right, I'm just going to say do 2 by 2 around my current position. And I simply hit scan, and off we go. It's going to go to the first spot, capture 7 Z planes, find the all-in-focus image, and then do the same for the other 3 images. So at the end here, we have our final product. Again, these are 4 images stitched together, each one with an EDF to create an all-in-focus image. I can now put scale bars, do measurements, and save this as an entire image. All right, to summarize our system, this is a great entry-level digital microscope system. We've taken, again, a traditional stereo microscope that's very upgradable in the future for camera technology that's going to come down the road. We've taken a nice XY motorized stage for XY image stitching, a motorized Z drive for your all-in-focus Z, and put it all together with Nikon's NIS element software, which makes it very easy to do all of these techniques that we've discussed. For more information on the system, please contact Mager Scientific.